Okay, so let us now first take up internally indeterminate truss. Okay, so we are given this truss, no, and supported by a pin at the left end and a roller at the right end. So if you count the number of support unknown reactions, you have 2 at the pin and 1 at the roller, so equal to 3 unknown support reactions. Okay, but using the 3 equations of equilibrium, you can determine the unknown support reactions. But looking at the configuration of the truss, there is an X bracing at the middle panel, no? Okay, so obviously, this X bracing makes the truss indeterminate. So to check, so we count the number of members. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the number of members is equivalent to 10. And the number of unknown reactions equal to 3. The number of joints, 1, 2, 3, 4, 5, 6. So our criteria is B plus R equal or greater than 2 times J. So we have 10 plus 3 is greater than 2 times 6. So 13 is greater than 12. So therefore, this truss is statically indeterminate to the first degree. Okay. Now, it is said that a truss is completely analyzed if you can determine all the forces of the members of the truss. Okay. So, force method of analysis can be applied in this internally indeterminate truss. Okay, so considering this truss, since it is statically indeterminate to the first degree, so na usa ka member niya nga mo ay nakapa-indeterminate. So in the force method of analysis, okay, so kuha sa nimo ng usa ka member nga mo ay nakapa-indeterminate, no? So in the middle panel there is an X bracing. So, pwede bisag asa ani nga bracing ang imong kuhaon. So, it's either EC or BF. So, assuming ang BF ang himuon nato nga redundant. So, we say redundant since it is an extra member or ang imong kuhaonon nga member. So, we call that redundant. Okay, so we take the redundant BF. So what will happen now to the truss? So it will become a determinate truss. Okay, so it will become a determinate truss. Okay, so when we take out the member BF, we determine now the delta or the displacement along the cut member BF. Okay, so we call that delta BF. Then we apply the member BF. Kaya mo siyang gitangtang. So, imo ra po siyang i-balik. So, along this cut member, we solve for the lowercase displacement delta BF BF. So, kaning double subscript, this is the member BF, no, caused by represents the relative displacement of the cut ends of member BF caused by a real unit load acting at the cut ends of the member BF. Okay, so manang double subscript siya BF BF. Okay, now we apply, so in our virtual load method, okay, so ang imong gamiton ani nga method in determining for the displacement is only by virtual load. Okay, so we apply a pair of unit load in the cut member BF. Okay, so pagkuha nimo sa delta BF dire, you solve for the forces of the truss due to the given loadings, and then you apply a pair of unit load in the direction of member BF. Okay, so delta BF then can be determined using the expression, diba, mao na itong formula pag solve delta BF is equal to summation of NNL over AE. Okay, so where small n is the bar forces of a pair of unit load and capital N is the bar forces of the real loads, this one, times L over AE. Okay, so these two configurations or trusses, similar ra sila, di ba? So if this is the displacement FBF-BF of a pair of unit load, okay, yung applyan na nimo siya sa bar force nga FBF-BF, mo himo po siya og displacement. Okay, so if this is the displacement due to a pair of unit load, parehas sila configuration, and this is delta BF-BF. Therefore, this delta BF-BF is FBF-BF times the bar force FBF. Okay, so ug mao ni ang iyang displacement due to a pair of unit load, parehas sila figure, di ba? So kung butangan ni siya 10 kilonewtons nga FBF-BF, so ang imong displacement din will be 10 times the displacement ani due to a pair of unit load. Parehas man sila configuration. Ang balikon ha. So kani kung mao na ang displacement due to a pair of unit load, kung applyan na nimo siya kibale, for example, kani nga bar force BF is 10 kilonewtons. So meaning ang imong displacement ani will be 10 times the displacement dire. So mao nang ang imong lowercase delta BF-BF is equal to FBF-BF times the bar force BF. Now kaning FBF-BF is called the flexibility coefficient. Okay, and how to solve for the flexibility coefficient? So mao ni kibali ang imong real loads. By virtual work method, maghimo na pug kaglaing inani nga applyan na po nimo og pair of unit load. Okay, so maghimo na pug kag inani. Okay. Okay. So kani man ang imong solbon, ang displacement due to pair of this loading. Okay, so kani nga displacement ha. So kini kibali mao ni ang imong real load. So mag-apply na pug ka og another pair of unit load. So mao na ni imong real load. So that would be your bar forces of a pair of unit load. Yung mag-apply na pug kaglaing pair of unit load. So mao nang ang imong flexibility coefficient will now become the summation of NNL over AE, or N squared L over AE. Now, since ang given is tama na siya bracing diha, so there should have been no displacement. So when you add the displacement nga wala ang BF, delta BF, nga imo nang gi-apply ang FBF, mo na yung displacement. So kung imo na siyang i-add, so we call that the compatibility equation. That should equal to 0. Okay, wala man kay displacement ganhi, kay bracing man ni siya. So manang delta BF plus the lowercase delta BF should equal to 0. But this one is equal to the product of the flexibility coefficient times the bar force BF. Okay? So, i-apply, substitute nimo ning delta BF and the flexibility coefficient in your compatibility equation. So, you can now solve for the bar force BF. So, after determining the bar force BF, so, imo na siyang i-apply diri So, mag-solve na nimo ang ubang mga bar forces. Okay? So, I hope that would be understood if you will have a sample problem.